Hello everyone, welcome back to the Microservice Masterclass. In the previous video, we learned about the service granularity and how to decide the right size of a microservice. Today we are going to learn one of the most important concepts in a cloud native architecture, stateless versus stateful services. This topic is asked in almost every senior software engineer, tech lead or solution architect interviews. More importantly, if you are working with a Kubernetes, AWS ECS, Docker, or a Spring Boot microservices, understanding this concept is essential. By the end of this lesson, you will be able to answer the following questions like why are stateless services preferred? Why does Kubernetes love stateless application? Why do we use Redis? What are the sticky sessions? And how does JWT make API stateless? So stay tuned. Let's begin. Let's start with the first panel of the diagram. What is state? Before understanding stateless or stateful services, we need to understand one simple word, state. State means information that an application remember between requests. Imagine you log into Amazon, you enter your username and password. After logging in, you browse the products, add items to your cart, place an order. How does Amazon know that every request belongs to you? Because it remembers your information. That remembered information is called state. Very simple. Look at the diagram. State includes user session, shopping cart, authentication token, temporary cached data, permanently cached, permanent permanent data in a database. Now think about a classroom. A teacher remember which student are present, who submitted homework and who's second the highest marks and who scored the highest mark sheet. That remembered information is also a kind of a state. The important question is where should we store this state? Should we keep it inside the application server or should we keep it in an external shared store like Redis or a database? This decision leads us to stateless or stateful services. Got it? Now let's see the stateless services. Move to the next green section of the infographic. A stateless service does not remember anything about previous request. A stateless service does not remember anything about previous request. Every request must contain all the information needed to process it. Imagine you are buying a coffee. Every time you visit to the counter, you clearly say one cappuccino with no sugar. The cashier doesn't remember what you ordered yesterday. Each order is complete by itself. That's exactly how a stateless service works. Look at the request response lifecycle in the diagram. Request 1 arrives with all required data. Right? This service process it, sends a response. Later request 2 arrives. The service treats it as a completely new request. It doesn't rely on memory of the request 1. Why this is powerful? Because every instance can process any request. Because any server instance can process any request. If one server crashes, another server can immediately take over. No user data is lost because nothing important was stored in a server memory. This is why stateless this is why stateless services are ideal for product search API, weather API, payment APIs, user profile APIs, REST APIs in general. And what is the benefits? As shown in the infographic, horizontal scaling, easy load balancing, better fault tolerance, fast deployment, auto scaling, cloud native design. Right? Now let's see the stateful service. What is stateful service? A stateful service stores client information inside the server itself. Imagine you visit a barber. The barber remembers your preferred hairstyle, your previous haircut, your preferred beard style. The next time you visit, he continues based on the what he remembers. That's the stateful interaction. Look at the request flow. Request 1 reaches server A. The session is stored in server A's memory. The now request 2 must also go to the server A. If it accidentally goes to server B, that server has no session information. The user may suddenly appear logged out. And this is why stateful service often require sticky sessions, where the load balancer always routes user back to the same server. Note this word. In the stateful services often require sticky session where the load balancer always routes a user back to the same server. Let's see the real world example. Traditional web applications, multiplayer game servers, web sockets, chat services, video streaming sessions, database servers such as MySQL, PostgreSQL. These are the one of the examples of the stateful services. And what is the advantage? Fast access to local session data. Right? Simpler to certain use cases, but it also has some disadvantages. And what are that? Difficult to scale. Server failure may lose sessions. Requires sticky sessions. Recovery is more complex. Okay. Now let's try to compare them. We'll have a more clear picture. Stateless versus stateful comparison. So, a stateless service don't store session on the server, scale horizontally very easily, will work well with any load balancer, are cloud native, are easier to deploy and replace. And the stateful service store session information locally, need sticky sessions, are harder to scale, require more careful failover planning. Think of it like a public library. If every library branch store all books digitally, you can visit any branch. That's stateless behavior. But if your reading history exists only in one branch, you must always return there. That is stateful behavior. Now let's move to the next topic. What is session management? Traditionally, a web applications store sessions on the server. The browser sends a session ID using cookies. The servers looked up the session in memory. This worked when there was only one server. But today, we often have many servers behind load balancer. Modern applications avoid storing session in memory. Instead, after login, the server issue a JWT, a web token. The client include this token in every request. Any server can verify the token. No server-side session is required. This makes authentication stateless and highly scalable. The next topic is external state storage. What if we really need to store state? The answer is simple. Store it outside the application. That's why infographic lists Redis, Memcached, database, object storage. For example, Redis stores user session and cached data. Database stores permanent information such as orders, customer details, and object storage stores images, videos, and documents. The application remains stateless because the state lives in shared storage. Right? Now let's move to the next topic, load balancing for stateless services. A load balancer request from users. Behind it are multiple stateless services instances. Since no instance stores user sessions, the load balancer can send each request to any healthy instance. This enables automatic scaling. If traffic doubles, Kubernetes or AWS ECS simply launches more containers. If one container crashes, another immediately replaces it. This is why prefers this is why Kubernetes strongly prefers stateless application. In AWS, services like ECS and EKS and Lambda are designed to work best with stateless workloads. If shared state is required, such as if shared state is required services such as Elastic Cache, DynamoDB can be used. Now let's move to the common mistake. Let's review the mistakes shown in the infographic. Storing a session only in application memory. Depending on a sticky session when they are not necessary. Saving files on the local container instead of shared storage. Assuming containers live forever. Losing user sessions after a deployment or server restart. These issues make application fragile and difficult to scale. Now let's see the best practices and key takeaways. Now let's finish the best practices. Always try to keep your service stateless. Store session in Redis or use JWT. Keep persistent data in databases. Design services so they can be started or stopped or replaced at any time. Avoid sticky sessions unless absolutely necessary. Finally, remember this one sentence. A stateless service can handle any request on any instance because it does not rely on server memory. That is the secret behind the scalability of companies like Amazon, Netflix, Google, and Uber. Now let's quickly recap the today's lesson. We learned what application state is and where it is should be stored. We explored the difference between stateless versus stateful service. We understood why stateless services are preferred in a modern microservices architecture. We discussed session management using cookies, JWT, and Redis. Finally, we saw Kubernetes and AWS are built around a stateless application. In the next lesson, we will cover API first design, where we will learn how to design clean, versioned, consumer friendly API that become the contract between microservices. If you found this lesson useful, don't forget to like, share, and subscribe. Thanks for watching, and I will see you in the next episode of the Microservice Masterclass. Till then, take care. Bye bye.